Close your eyes for a moment. Imagine yourself staring at the night sky, looking at a universe that feels solid, predictable, and permanent. We think that the silence of the universe means peace. But what if the silence itself is a warning? You think you're living just one life, but what if you are everyone who has ever lived? Or worse, you think the universe was created 13 billion years ago. But what if it was created only 5 days ago? Tonight, we'll be examining these theories from the terrifying silence of the dark forest to the infinite shelves of the Library of Babel. Theories that are not just fiction, but real mathematical and philosophical possibilities. We journey through the most unsettling answers to the mystery of our very existence. Just let the weight of the infinite carry you into sleep. One of the most fascinating questions about the universe begins with a very simple observation. The universe is incredibly large. Astronomers estimate that there are hundreds of billions of galaxies in the observable universe. Each of those galaxies contains billions, and sometimes even trillions of stars. Around many of those stars are planetary systems, much like our own solar system. In recent decades, scientists have discovered thousands of exoplanets, and many of them appear to exist in what is known as the habitable zone, the region around a star where conditions might allow liquid water to exist. When you begin to think about these numbers, the scale becomes difficult to grasp. To put this into perspective, imagine every beach on Earth, every desert, every riverbed, and every stretch of coastline. If you tried to count every grain of sand in all of those places combined, the number would be enormous. Yet many astronomers believe that the number of stars in the observable universe may actually be greater than the total number of grains of sand on Earth. With numbers this large, it seems statistically reasonable to expect that intelligent life might have emerged many times across the cosmos. Some civilizations could even be millions of years more advanced than we are. And yet, despite decades of searching the skies, listening for signals, and studying distant worlds, we have found no clear evidence of intelligent alien civilizations. This mystery led physicist Enrico Fermi to ask a famous question. If the universe is so full of possible life, where is everyone? One possible answer to this mystery comes from a concept known as the dark forest theory. The idea was popularized in the science fiction novel The Dark Forest, written by Chinese author Liu Cixin. The theory begins with a simple but unsettling metaphor. Imagine the universe as a vast, dark forest at night. In this forest, every civilization is like a hunter moving silently among the trees. Each one carries the ability to defend itself and perhaps the ability to destroy others. But because the forest is dark, no one can clearly see who or what might be nearby. You cannot know whether another hunter is peaceful or dangerous. In such a situation, making noise would be extremely risky. Calling out into the darkness might reveal your location to something far more powerful than you. So every hunter follows the same instinct. Stay quiet. No one announces their presence. No one signals where they are. Everyone hides, listening carefully in the darkness. According to the dark forest theory, the universe may function in a similar way. Intelligent civilizations could exist across countless star systems, but they remain silent, not because they are absent, but because revealing themselves could be dangerous. In a universe where the intentions and capabilities of other civilizations are completely unknown, the safest strategy may simply be to remain unnoticed. From this perspective, the silence of the cosmos might not be mysterious at all. It might be intentional. For the dark forest theory to make sense, it relies on a few basic assumptions about how intelligent civilizations might behave. These assumptions are not necessarily pessimistic. They are simply grounded in patterns we already observe in nature and in human history. The first assumption is that survival is the primary goal of any civilization. On Earth, every living organism, from the smallest bacteria to the most complex animals, shares one fundamental drive: to continue existing. Life adapts, competes, and evolves largely because survival is necessary for reproduction and long-term continuation. Human societies are not very different. Nations invest heavily in defense, technology, and resource security because maintaining stability and protecting the population is considered essential. Even cooperative societies ultimately prioritize survival when faced with existential threats. If intelligent civilizations arise elsewhere in the universe, it would be reasonable to assume that they follow a similar principle. Regardless of their culture, biology, or philosophy, they would likely place a high priority on ensuring their continued existence. The second assumption is that resources in the universe are limited. At first glance, the universe appears almost infinitely large. With hundreds of billions of galaxies and countless stars, it may seem as though there would be more than enough space and energy for everyone. But from the perspective of a growing civilization, resources such as usable energy, habitable planets, and stable star systems are still finite. Every civilization requires energy to sustain its technology and its population. Over long periods of time, thousands, millions, or even billions of years, an expanding civilization might need increasing amounts of matter and energy to maintain its development. If multiple civilizations exist and continue expanding outward into space, their interests could eventually overlap. Two civilizations might seek the same star system, the same planetary resources, or the same regions of space. This possibility introduces a difficult strategic problem. If survival is the highest priority and resources are not unlimited, then any unknown civilization could potentially become a future competitor. Even if they appear peaceful today, their needs and capabilities might change over time. Because of this uncertainty, the mere existence of another intelligent civilization could represent a potential risk. From this perspective, the universe becomes less like a peaceful community of civilizations and more like a cautious environment where each society must constantly consider the long-term implications of encountering others. These two assumptions, the drive for survival and the limits of resources, form the logical foundation of the dark forest theory. Once these ideas are accepted, the behavior of civilizations in the cosmic forest begins to look very different. This leads to what many consider the most unsettling part of the dark forest theory, the problem of intentions. Even if humanity were to detect another intelligent civilization somewhere in the galaxy, there would be no reliable way to know what their true intentions are. They might be peaceful, they might be curious, or they might see other civilizations as potential threats. The difficulty is that space is unimaginably vast. Even signals that travel at the speed of light can take years, decades, or even centuries to move between star systems. A message sent from one civilization might not receive a reply for generations. Because of this delay, communication cannot easily build trust. Misunderstandings cannot be quickly corrected, and intentions cannot be verified in real time. Imagine trying to determine whether a distant civilization is friendly when each exchange of messages takes hundreds of years. By the time you learn their true motives, it might already be too late to respond. This creates a frightening strategic dilemma for any advanced society. If a civilization reveals its location and existence, it risks attracting the attention of something far more powerful. But if it stays silent and hidden, it reduces the chance of being discovered. In such a universe, silence may not be loneliness. It may simply be self-preservation. The most disturbing implication of the dark forest theory emerges from the logic of survival itself. If civilizations cannot know the intentions of others, then even a peaceful neighbor could become a dangerous threat in the future. From a strategic perspective, waiting might be the most dangerous choice. Imagine discovering a distant civilization that is still less advanced than your own. At the moment, they may pose no immediate danger. But over thousands or millions of years, they could develop new technologies, expand into space, and eventually gain the ability to threaten your civilization. Because communication across interstellar distances is slow and uncertain, there is no reliable way to guarantee long-term trust. Promises cannot be enforced, and misunderstandings could escalate over centuries. Under these conditions, some civilizations might conclude that the safest strategy is preemptive action. In other words, eliminating a potential rival before it becomes capable of posing a real threat. Importantly, this logic does not require a civilization to be aggressive or malicious. Even a highly rational and cautious society could arrive at the same conclusion if survival is its highest priority. In a universe where extinction is the ultimate risk, the fear of what another civilization might become could be enough to justify striking first. Imagine walking alone through a forest at night. The trees are dense, the air is quiet, and visibility is almost non-existent. Somewhere out there, you know that other hunters may be moving through the darkness. You cannot see them. You cannot know whether they are peaceful, cautious, or dangerous. In such a situation, the safest choice is simple, and that is to stay silent. You move carefully, avoiding any noise that might reveal your position. You listen closely, watching for any sign that someone else is nearby. According to the dark forest theory, the universe may operate in much the same way. Every civilization remains hidden, listening, watching, and hoping not to be noticed. The dark forest idea is not only a thought experiment in fiction. It also connects to real debates among scientists about how humanity should behave in the search for extraterrestrial intelligence. For decades, projects such as SETI, or the Search for Extraterrestrial Intelligence, have attempted to detect signals from advanced civilizations beyond Earth. The goal is simple: to listen for signs that we are not alone in the universe. But some scientists have raised a cautious concern. If the universe truly resembles a dark forest, then broadcasting our presence might carry unknown risks. For example, theoretical physicist Stephen Hawking once warned that contacting highly advanced civilizations could be dangerous if they were far more powerful than us. In such a scenario, revealing our location might not necessarily be wise. Ideas like this remind us of something important. Our understanding of the universe is still incomplete, and if our assumptions about other civilizations can be questioned, perhaps even our assumptions about the beginning of the universe itself deserve to be questioned as well. That's what the next theory is all about. We can start with a simple observation about how we understand the past. Everything we believe about earlier events is based on evidence that exists in the present moment. We remember our childhood through memories stored in our minds. Historians study written records and documents left behind by earlier generations. Photographs and videos preserve moments that appear to show what happened before. Scientists also rely on present evidence to study the distant past. Fossils and geological layers reveal clues about life on Earth millions of years ago. Astronomers observe light from distant stars and galaxies, allowing them to look billions of years back into cosmic history. But there is something interesting about all of this evidence. Every memory, every record, every fossil, and every beam of starlight is something we observe right now. This leads to a surprisingly difficult philosophical question. If all evidence of the past exists only in the present, how can we prove that the past actually happened the way we think it did? One thought experiment that explores this question is known as last Thursdayism. The idea proposes something intentionally strange. What if the universe was created only recently, perhaps as recently as last Thursday? According to this thought experiment, the universe could have been created in a fully formed state, complete with everything we currently observe. All memories would already exist in our minds. Historical records, photographs, and written documents would already be in place. From our perspective, it would appear as though history had unfolded normally over many years. Scientists would still discover ancient fossils buried in the ground. Geological layers would still suggest that Earth is billions of years old. Astronomers would still observe galaxies whose light appears to have traveled for billions of years across space. Yet in this scenario, none of those events would have actually happened. Instead, the universe would simply have been created with the appearance of a long history, even though that history never truly occurred. At first glance, the idea of last Thursdayism may sound absurd. Yet the reason philosophers discuss it is not because they believe it to be true, but because it highlights an interesting problem about how we verify knowledge. The central point is surprisingly simple. There is no direct test that could prove the universe was not created last Thursday. The reason lies in how evidence works. Any attempt to investigate the past relies on information that exists in the present. When we try to verify history, we examine memories, written records, physical artifacts, or natural traces left behind by earlier events. But if the universe had been created recently in a fully formed state, all of those forms of evidence could have been created at the same time. Your memories would still seem authentic. You would remember conversations, experiences, and moments from years ago. Those memories would feel just as vivid and convincing as they do now. Physical records would also appear completely normal. Books, photographs, videos, and historical documents would all contain detailed accounts of events that appear to have taken place long before the present moment. Scientists would encounter the same situation when studying nature. Geological layers would still show signs of ancient Earth processes. Fossils would still appear to represent organisms that lived millions of years ago. Even the light arriving from distant galaxies, light that seems to have traveled billions of years across space, would still be observable through telescopes. In the framework of last Thursdayism, all of this evidence could simply be part of the universe as it was initially created. Because of this, any test we perform would still produce results that appear consistent with a long cosmic history. Every piece of evidence we examine would reinforce the same conclusion, that the universe has existed for billions of years. But if the universe had actually been created recently, with all of that evidence already in place, then our observations would still look exactly the same. This is why the idea cannot be easily disproven. Any evidence we might use to challenge the claim would itself be part of the very system we are questioning. Of course, philosophers generally do not suggest that the universe truly began last Thursday. Instead, the thought experiment serves a deeper purpose. It illustrates that our knowledge of the past is always based on interpreting evidence that exists in the present moment. Science operates on the assumption that the universe behaves consistently, and that evidence reliably reflects past events. This assumption works extraordinarily well and allows us to build accurate models of history and cosmology. But ideas like last Thursdayism remind us that absolute certainty about the past is philosophically difficult to achieve. Our understanding ultimately depends on trusting that the evidence we observe today genuinely reflects events that occurred before now. Last Thursdayism belonged to a long tradition in philosophy known as skepticism. Philosophical skepticism explores the limits of what we can truly know about reality. Throughout history, philosophers have proposed similar thought experiments to challenge our assumptions. For example, the philosopher René Descartes famously asked whether our senses might sometimes deceive us. He wondered if it was possible that everything we perceive could be part of an elaborate illusion, similar to a very convincing dream. In more modern discussions, philosophers have raised comparable questions in different forms. For instance, Nick Bostrom proposed the idea that advanced civilizations might one day simulate entire universes, raising the possibility that our own reality could exist inside such a simulation. Last Thursdayism fits within this tradition. It is essentially a playful, modern version of these skeptical ideas, designed not to assert a belief, but to challenge how we think about knowledge and certainty. The deeper message behind last Thursdayism is not about doubting everything we know, but about recognizing the limits of certainty. In everyday life, we rely heavily on memories, records, and scientific evidence to understand reality. These sources are extremely useful and generally reliable. However, they all depend on an underlying assumption that the universe behaves in a stable and consistent way, and that evidence today genuinely reflects events that occurred in the past. Thought experiments like last Thursdayism remind us that absolute certainty about reality may be difficult or even impossible to achieve. Even our most trusted memories and historical records are ultimately interpretations of information available in the present. Philosophy uses ideas like this not to undermine knowledge, but to clarify how knowledge works. Instead of perfect proof, our understanding of the world is built on reasonable trust in evidence, careful observation, and the consistent patterns we see in nature. Rather than something unsettling, ideas like this can be seen as humbling. The universe may be far stranger than we currently understand, and our knowledge continues to evolve as we learn more. In many ways, this uncertainty is what drives curiosity, encouraging us to keep exploring, questioning, and searching for deeper understanding. Thought experiments like this remind us that reality can sometimes be far stranger than our everyday assumptions. Yet philosophy is not the only field that raises unsettling possibilities about the nature of the universe. In fact, modern physics has another idea that pushes our imagination even further. It suggests that the laws of reality we experience might not be the most stable ones possible. Some physicists propose that our universe could exist in what is called a false vacuum, a temporary state of physical stability. And if that is true, a sudden transition to a true vacuum could occur, spreading across space at the speed of light, instantly rewriting the laws of physics everywhere. Most of us grow up assuming that the universe operates under stable and unchanging rules. The laws of physics seem reliable. Gravity pulls objects toward one another. Light travels at a constant speed. The forces that govern matter, such as electromagnetism and nuclear interactions, appear consistent wherever we observe them. Because these patterns have held true throughout all of recorded scientific observation, it feels natural to assume they will always remain the same. But modern physics introduces a surprising possibility. The laws of physics we observe might not represent the most stable state the universe can have. Instead, the universe we live in could exist in a temporary configuration, one that has remained stable for billions of years, but may not be the final state of reality. To understand this idea, we first need to clarify what physicists mean by the word vacuum. In everyday language, a vacuum usually means completely empty space, an area with no matter, no air, and nothing inside it. But in modern physics, the concept is more complicated. According to quantum field theory, even what we call empty space is not truly empty. Instead, space is filled with invisible structures known as quantum fields. These fields exist everywhere in the universe and are responsible for the behavior of fundamental particles. Even when there are no particles present, these fields still exist and contain energy. Tiny fluctuations constantly occur within them, creating brief changes in energy that appear and disappear on extremely short timescales. Because of this, the vacuum of space is actually a dynamic environment rather than a perfect void. When physicists refer to a vacuum state, they are talking about the configuration of these fields when they are at their lowest possible energy level. You can imagine it as the most stable arrangement the universe can settle into. However, the important question is whether the state our universe currently occupies is truly the lowest energy state possible, or whether it might only appear stable, while an even lower energy state exists somewhere deeper. To explain this idea, physicists often describe two possible states that the universe could occupy: the false vacuum and the true vacuum. A false vacuum is a state that appears stable, but is not actually the lowest possible energy configuration of the universe. In other words, it can remain stable for an extremely long time, yet it is still not the most stable state that could exist. A helpful way to imagine this comes from a simple analogy. Picture a landscape of hills and valleys. If you place a ball in one of the valleys, the ball will settle there and remain still. From the ball's perspective, it appears to be in a stable position. But not all valleys are equally deep. Sometimes a valley may only be a shallow depression in the landscape. The ball can rest there for a long time, but somewhere nearby, there may exist a deeper valley, a lower point where the ball would ultimately be more stable if it ever reached it. This is similar to what physicists mean by a false vacuum. In this scenario, the universe behaves as if it is stable. The laws of physics remain consistent, particles behave in predictable ways, and the structure of matter remains intact. From everything we observe, reality appears to be functioning normally. But beneath that stability could lie an even lower energy configuration of the universe. This deeper state is called the true vacuum. The true vacuum represents the absolute lowest energy state possible for the fields that make up the universe. If the universe were to reach this state, it would be more fundamentally stable than the one we currently experience. The unsettling possibility suggested by some theories in particle physics is that our universe might not yet be in that deepest valley. Instead, it may be resting in a false vacuum, a state that has remained stable for billions of years, but is not the ultimate ground state of reality. If that were the case, then somewhere in the vast landscape of physical possibilities, a transition to the true vacuum could still occur. And if such a transition ever began, it would not simply change one region of space. It could potentially transform the very structure of physics itself. If the universe were ever to transition from a false vacuum to a true vacuum, the process would likely begin with something incredibly small, Instead of the entire universe changing all at once, the transition would start in a tiny region of space. In that small region, the quantum fields that define the structure of reality would suddenly settle into the true vacuum state, the lowest possible energy configuration. This moment would create what physicists often describe as a bubble of true vacuum. At first, the bubble might be extremely small, perhaps even microscopic, but inside that bubble, the rules of physics would no longer be exactly the same as the ones that govern our universe today. The fundamental constants that shape reality could be different. The strengths of forces such as electromagnetism or the nuclear forces might change. Particles that currently exist could behave in completely different ways. In fact, it is possible that some of the structures we rely on, such as stable atoms, might not exist at all in this new configuration. Atoms form because the laws of physics allow electrons to orbit atomic nuclei in predictable ways. But if the constants governing those interactions changed, atoms might not be able to hold together. Matter, as we understand it, could become unstable. Inside the bubble of true vacuum, the basic ingredients of the universe might reorganize into forms completely unfamiliar to us. Importantly, this transition would not require an external cause like a collision or explosion. According to some interpretations of quantum field theory, such transitions could occur spontaneously through quantum processes, although the probability may be extremely small. If such a bubble ever formed, it would mark the beginning of a profound transformation. The region inside the bubble would follow the new laws of physics, while the universe outside would still obey the old ones, at least for a brief moment before the bubble began to expand. Once a bubble of true vacuum formed, it would not remain small for long. According to theoretical models in modern physics, the boundary of the bubble would begin expanding outward through space, and it would do so at an extraordinary speed, the speed of light. As the bubble expands, everything it touches would instantly transition into the new vacuum state. The quantum fields that define the structure of reality would rearrange themselves into the lower energy configuration. In that moment, the familiar laws of physics that govern our universe would no longer apply within that region. Because the bubble expands at the speed of light, there would be no way to detect it before it arrives. No signal can travel faster than light, which means no warning could reach us in advance. From our perspective, the event would be completely sudden. One moment, the universe would appear normal. The next moment, the expanding boundary of the new vacuum would reach our region of space, instantly replacing the physics that allows atoms, stars, planets, and life itself to exist. There would be no time to react, no time to observe it approaching. The universe, as we experience it, would simply change in an instant. The idea of false vacuum decay may sound like science fiction, but it actually arises from serious work in modern physics. The concept is rooted in quantum field theory and in cosmology, the study of the universe's origin and evolution. One reason physicists discuss this possibility comes from research involving the Higgs field. Measurements related to the Higgs particle suggest that the vacuum state of our universe might be metastable, meaning it appears stable, but may not be the absolute lowest energy state possible. This does not mean a transition will occur, but it shows that such scenarios naturally appear in our current understanding of particle physics. At the same time, scientists emphasize that even if false vacuum decay is theoretically possible, it is extremely unlikely to happen anytime soon. Calculations suggest that such a transition might take far longer than the current lifetime of the universe, and it may never occur at all. In other words, the idea does not imply immediate danger. Instead, It highlights just how subtle and complex the fundamental structure of reality may be. Stepping back, each of these ideas challenges a different assumption we normally take for granted. The egg theory asks us to reconsider identity and whether consciousness might be more connected than we think. The dark forest theory questions whether the universe is a safe place for intelligent civilizations. Last Thursdayism challenges our confidence in the past itself, and false vacuum decay raises an even stronger possibility that the very laws of physics we depend on might not be permanently stable. Together, these ideas point toward a humbling conclusion. The universe may be far stranger than our everyday intuition suggests. But there is another thought experiment that pushes this uncertainty even further. Imagine an infinite library containing every possible arrangement of letters. Somewhere inside it would be every book ever written, and every book that will ever be written. But it would also contain books that describe events that have not yet happened. What if one of those books already contains the story of your entire life, including how it ends? Imagine a vast, infinite library. Its rooms stretch endlessly in every direction, each one lined with identical shelves filled with books. Every book follows the same structure, the same number of pages, the same number of lines on each page, and the same set of characters from a fixed alphabet. But the letters inside these books are arranged in every possible way. Most books contain meaningless strings of characters. Yet because the library is infinite, every possible combination of letters must exist somewhere within it. This unusual concept originates from the short story The Library of Babel, written by Jorge Luis Borges. If a library truly contains every possible arrangement of letters, the implications become extraordinary. Any book that could ever be written using that alphabet and that page format would already exist somewhere on its shelves. This means the library would contain every novel ever written in human history, every scientific paper, every philosophical text, every poem, and every story that has ever been recorded would already be present in some volume. But the library would not stop there. It would also contain books that have not yet been written. Future discoveries, inventions, and histories would already be found somewhere in the endless collection of volumes. At first, this sounds like an incredible treasure of knowledge. Yet the reality of such a library would be far less orderly. Because every possible combination exists, the overwhelming majority of books would contain nothing but meaningless sequences of letters. Others might look almost correct, perhaps identical to a famous novel, except for a single letter changed somewhere on one page. There would be millions of nearly identical versions of the same book, each differing by only a tiny error. In fact, meaningful books would be incredibly rare compared to the vast ocean of nonsense surrounding them. Once we accept that every possible arrangement of letters exists somewhere in the library, the implications become more personal and a little unsettling. Among the endless shelves, there would be a book that tells the complete story of your life. Every event you have experienced, every decision you have made, and every moment you have lived would appear in perfect detail across its pages. Somewhere else in the library, there would be another book containing every conversation you will ever have, every word you will speak, every message you will send, and every thought you will express could already exist in written form. And deeper within the endless corridors, there would also be a book describing the exact moment your life ends, including the date, the circumstances, and the final events leading to it. What makes this idea unsettling is that these books would not exist because someone intentionally wrote them. They would exist simply because every possible sequence of letters must appear somewhere in an infinite library. In that sense, the library would not just contain stories about imaginary worlds. It would also contain every possible version of your own life. Once we accept that every possible arrangement of letters exists somewhere in the library, the implications become far more personal and far more unsettling. Among the endless shelves, there would be a book that tells the complete story of your life. Every event you have experienced, every decision you have made, and every moment you have lived could appear in perfect detail across its pages. Somewhere else in the library, another book would contain every conversation you will ever have. Every sentence you will speak, every message you will send, every question you will ask, and every answer you will hear could already exist in written form. And somewhere deeper within the infinite corridors of shelves, there would also be a book that describes the final chapter of your life, the exact date, the circumstances, and the moment it ends. What makes this idea unsettling is that none of these books would exist because someone deliberately wrote them. They would exist simply because every possible combination of letters must appear somewhere in an infinite collection. In such a library, every possible story must exist, including stories that describe real lives with perfect accuracy. Yet the existence of these books creates another, even more troubling problem. Even if the correct book exists somewhere in the library, finding it would be almost impossible. An infinite library containing every possible book would also contain an overwhelming number of meaningless ones. Most volumes would be filled with random sequences of letters that form no words, no sentences, and no understandable ideas. Page after page would appear as complete nonsense. Even books that look meaningful at first glance might contain subtle errors. A biography of your life might exist, but there could also be millions of nearly identical versions where a single letter is wrong, a date is slightly different, or an event is described incorrectly. There might be a book that almost perfectly predicts the future, except for one small mistake hidden somewhere in its pages. Because the library contains every possible combination, the number of incorrect or meaningless books would vastly outnumber the meaningful ones. In practice, this means that truth would be buried inside an unimaginable ocean of noise. Imagine wandering through endless hallways filled with bookshelves, knowing that somewhere among them is a book that answers every question you have ever asked. Yet the vast majority of the books surrounding it contain nothing but nonsense. This creates a strange paradox. A library that contains all possible knowledge does not necessarily make knowledge easier to obtain. In fact, it may make it far harder. When every possible answer exists, the real challenge is no longer whether the answer exists, but whether it can ever be found. The scale of the Library of Babel becomes even more striking when we look at it from a mathematical perspective. Even with strict limitations, the number of possible books grows to an unimaginable size. Imagine that every book in the library follows the same format. Each one contains 410 pages. Every page has 40 lines, and each line contains 80 characters chosen from a fixed alphabet of symbols. At first, this may sound like a manageable structure, but the mathematics of combinations quickly reveals something astonishing. Every single character position in the book could contain any letter from the alphabet. When you multiply those possibilities across hundreds of thousands of character positions, the number of different books that can exist becomes astronomically large. In fact, the number of possible books created from such a format would exceed the estimated number of atoms in the observable universe. And according to the thought experiment, the Library of Babel contains every one of those books. Some of them contain meaningful sentences, scientific discoveries, and works of literature. But the overwhelming majority would be filled with random characters that form no coherent message at all. This mathematical explosion of possibilities is what gives the library its strange and overwhelming nature. Yet the story imagined by the Library of Babel is not really about a literal infinite building filled with books. Instead, the library serves as a metaphor for something deeper. It represents the limits of human knowledge. Within the library, the inhabitants, often called librarians, spend their lives wandering through endless halls, searching for meaning among the countless volumes. Many believe that somewhere there must exist a special book, a book that explains the structure of the library itself, or a book that reveals the ultimate truth about existence. But even if such a book exists, the sheer size of the library makes finding it almost impossible. In this way, the story reflects a profound philosophical question about the nature of knowledge. Human beings live in a universe filled with enormous amounts of information, patterns, and possibilities. Yet understanding that information requires sorting meaning from chaos. The Library of Babel pushes this idea to its extreme. If every possible text exists somewhere in the library, then every possible idea exists as well. Somewhere within the shelves, there would be a book proving that your life has deep meaning and purpose. Somewhere else, there would be a book arguing the exact opposite. There would be books predicting countless different versions of the future, some accurate, some mistaken, and many completely contradictory. In such a library, every truth and every falsehood would coexist. This leads to a deeply unsettling question. If every possible answer exists somewhere, and if every explanation can be written in some book, then how do we determine which ones are actually true? The challenge is no longer whether knowledge exists. The challenge becomes knowing which knowledge to trust. The Library of Babel leaves us with a quiet but profound realization. Information alone does not guarantee understanding. Even if every possible answer exists somewhere, meaning is not automatically revealed. It still requires interpretation, judgment, and the difficult task of separating truth from endless noise. In a universe overflowing with possibilities, knowledge becomes something we must patiently search for, rather than something easily given. But the Library of Babel also raises another unsettling possibility. If every possible story exists somewhere, then some of those stories would describe the same life repeating again and again, unchanged each time. What if your life, every choice, every mistake, every moment of happiness and regret, were destined to happen exactly the same way, forever? To explore that question, we have to turn to our last idea in philosophy, which is eternal recurrence. Imagine being told that your life will repeat exactly as it has happened, over and over again, for eternity. Every event you experience, every decision you make, every moment of joy, embarrassment, success, and regret would unfold in precisely the same way each time. Nothing would change. Nothing could be altered. It would not be a slightly different life or a new version of your story. It would be the exact same life, repeated infinitely. This unsettling thought experiment is known as eternal recurrence, an idea most famously explored by the German philosopher Friedrich Nietzsche. To present this idea, Friedrich Nietzsche imagined a striking thought experiment. He asked readers to picture a demon suddenly appearing and delivering a message: "This life exactly as you now live it, you must live once again and innumerable times again. Nothing would be different. Every joy you experience, every embarrassment you remember, every mistake you regret, and every moment of happiness would return exactly the same. You would relive the same conversations, the same choices, and the same outcomes forever. Nietzsche then posed a simple but profound question. How would you react to hearing that your life must repeat this way for all eternity? The idea of eternal recurrence was not necessarily meant to be taken as a literal description of how the universe works. Instead, it functions as a philosophical test, a way of examining how we feel about the lives we are living. According to Friedrich Nietzsche, imagining the endless repetition of our lives can reveal something important about our values and choices. If the thought of reliving your life exactly as it is feels terrifying, it may suggest that there are parts of life filled with regret, moments you wish had unfolded differently, or decisions you wish you could undo. But if the idea feels meaningful or even joyful, it could mean that your life contains experiences you would willingly embrace again and again. In this sense, eternal recurrence becomes a powerful question rather than a prediction about reality. It asks us to reflect deeply. Are you living a life you would be willing to live again forever? Although Nietzsche presented the idea as a philosophical challenge, the concept has occasionally appeared in discussions about cosmology as well. Some theoretical models of the universe propose that the cosmos might undergo endless cycles of expansion and collapse. If such cycles repeated indefinitely, it raises the possibility that the arrangement of matter in the universe could eventually occur in the same way again. In theory, this could lead to the same events unfolding once more across vast cosmic timescales. However, most physicists do not consider eternal recurrence a realistic prediction of the universe. Instead, it remains primarily a philosophical idea, one designed to provoke reflection about how we live and what we truly value in the time we have. The idea of eternal recurrence becomes powerful when we begin to apply it to the small details of everyday life. If every moment were destined to repeat exactly as it happened, then even the most ordinary actions would take on a new level of significance. Under this perspective, each choice would echo infinitely into the future. Every act of kindness you show to someone will be repeated forever. Every moment of patience, generosity, or compassion would occur again and again across endless cycles of existence. But the same would be true for mistakes. Every harsh word, every regret, every moment of anger or carelessness would also repeat without end. Nothing could be undone, and nothing could be erased. Seen this way, eternal recurrence transforms ordinary life into something far more meaningful. The smallest decisions begin to matter because they will not happen only once. They would become permanent features of an endlessly repeating life. In this sense, the idea encourages a deeper awareness of how we live each day. Every moment becomes something that might be worth embracing fully, rather than something to rush past or overlook. This leads directly to the deeper existential question behind the thought experiment. If you were told that your life would unfold exactly as it has, every success, every embarrassment, every moment of happiness and sorrow, repeating again and again for eternity, how would you feel? Would the idea feel like a punishment, trapping you in an endless cycle of the same experiences? Or would it feel like a strange kind of affirmation, a life so meaningful that you would willingly live it again forever? The answer to that question may reveal something profound about how you truly feel about the life you are living. As we reach the end of this journey through strange ideas about the universe, it becomes clear that each of these thought experiments asks us to question something we usually take for granted. The egg theory invites us to reconsider who we are, suggesting that consciousness itself might be far more connected than we imagine. The dark forest theory challenges our assumptions about the cosmos, raising the unsettling possibility that intelligent civilizations may hide in silence out of fear. Last Thursdayism reminds us that our understanding of the past is built entirely on evidence we observe in the present moment. The idea of false vacuum decay pushes even further, suggesting that the very laws of physics we depend on might not represent the most stable state of reality. And the Library of Babel confronts us with the overwhelming nature of information, showing that even if every possible answer exists somewhere, finding the right one may still be nearly impossible. Each of these ideas expands the boundaries of how we think about existence. But eternal recurrence turns the question inward. Instead of asking about the universe, it asks about your life. If every moment you experience, the good and the painful, the joyful and the regrettable, were destined to repeat exactly the same way forever, how would you feel about it? Would it feel like an endless burden? Or would it feel like a life meaningful enough to live again and again? Perhaps the quiet power of this idea lies in the question it leaves behind. If your life were repeated forever, would you welcome it? For centuries, philosophers have used thought experiments to explore deeper questions about consciousness, identity, and morality. The egg theory is no exception. This is one idea about the universe that is not meant to be taken as a literal explanation of reality, but rather one that would give a whole new meaning to reality, if this is true. The egg theory originated from the short story by Andy Weir, titled The Egg. The story itself is simple, almost like a modern fable. A man dies and finds himself speaking with a godlike being. During their conversation, he learns something surprising about the universe, something that completely reframes his understanding of life. But the purpose of the story isn't to claim that the universe literally works this way. Instead, it invites us to reflect on a deeper question. What if the boundaries between people are not as separate as we think? Philosophy often works this way. A strange idea is introduced, not because it is proven to be true, but because exploring it can reveal something about ourselves. In that sense, the egg is not about cosmology, and more about perspective. It asks us to imagine a universe where every life is connected in a way we normally never consider. And once you begin thinking about it, the implications become surprisingly profound. To understand why ideas like the egg theory appear in philosophy, we first have to look at one of the biggest unanswered questions about the human mind: consciousness. Every moment of your life is filled with experience. You see colors, hear sounds, feel emotions, and think thoughts. From the inside, this seems completely natural. But when scientists try to explain it, something strange appears. Neuroscience can describe what the brain is doing. It can show which neurons fire when you see a color, remember a memory, or feel happiness. But even if we mapped every electrical signal in the brain, a deeper mystery would still remain. Why does any of this create experience at all? Why isn't the brain just a complex machine processing information in total darkness? This question is known as the hard problem of consciousness, a term introduced by philosopher David Chalmers. The problem is not explaining how the brain works. Science has made enormous progress there. The problem is explaining why there is something it feels like to be you. Why is there a point of view inside your mind? Because of this mystery, some philosophers have wondered whether consciousness might be more fundamental to reality than we usually assume. And once that possibility is considered, strange ideas, like the one described in the egg, begin to feel a little less impossible. Another idea that brings us closer to the themes of the egg is a philosophical position known as idealism. In everyday thinking, we usually assume that the physical world is the most fundamental thing that exists. Matter comes first, and consciousness is simply something produced by the brain. In this view, the mind is more like a byproduct of physical processes. But idealism flips that assumption completely. Instead of saying that matter creates consciousness, idealism suggests that consciousness might actually be the fundamental thing in the universe, and that what we call the physical world emerges from it. One modern philosopher who argues for a version of this idea is Bernardo Kastrup. In his view, the universe may be comparable to a vast field of mind, where individual conscious beings are not completely separate entities, but rather localized perspectives within a larger consciousness. An analogy sometimes used is that of waves in an ocean. Each wave appears separate from the others, yet all of them are expressions of the same body of water. If something like this were true, the boundaries between individuals might not be as absolute as they seem. And suddenly, the central idea of the egg, that every life could be another expression of the same consciousness, starts to sound less like pure science fiction and more like a philosophical possibility worth considering. Interestingly, ideas similar to the one explored in the egg are not limited to modern philosophy or science fiction. Versions of this idea have appeared in ancient philosophical and spiritual traditions as well. For example, within Hinduism, there is a concept often discussed in the philosophical texts known as the Upanishads, the relationship between Atman and Brahman. Atman refers to the inner self, the deepest essence of an individual person. It is not simply the personality or the ego, but the core awareness that experiences life. Brahman, on the other hand, refers to the ultimate reality of the universe. It is described as the fundamental, universal consciousness that underlies everything that exists. In some interpretations of these teachings, a profound idea emerges. The individual self and the universal self are not truly separate. At the deepest level of reality, Atman and Brahman are the same. In other words, the consciousness within each person may ultimately be an expression of a single, universal consciousness. When viewed from this perspective, the central idea behind the egg, that every life could be another perspective of the same awareness, begins to resemble philosophical ideas that have been explored for thousands of years. What first sounded like a strange story now begins to look more like a recurring theme in humanity's attempts to understand the nature of consciousness itself. Beyond philosophy, the idea behind the egg also carries an interesting psychological and ethical implication. It asks us to reconsider why we choose to be good to others in the first place. In everyday life, morality is often explained through rules. We are told to treat others well because society expects it, because laws demand it, or because certain actions are considered right or wrong. These rules help maintain order, but they usually assume that individuals are fundamentally separate from one another. The perspective suggested by the egg changes that assumption. If every person you encounter is, in some sense, another version of the same consciousness, then the motivation for kindness becomes very different. Helping another person would no longer just be an act of generosity, it would also be an act directed toward yourself. In this view, the ethical principle becomes simple. Every action eventually returns to the one who performs it. Ideas that resemble this appear in many different traditions. Concepts like karma in Eastern philosophy, the golden rule found in many religions, and modern discussions about empathy all suggest a similar intuition. The way we treat others shapes the world we ultimately experience. The egg theory pushes that idea to its extreme. It imagines the ultimate form of empathy, where every act of kindness, patience, or compassion is quite literally something you are doing for yourself. At a deeper level, the idea behind the egg speaks to two fears that many people quietly carry throughout their lives: the fear of insignificance and the fear of being alone. Human beings often wonder whether their lives truly matter in the vastness of the universe. At the same time, even when surrounded by others, many people still experience a subtle sense of separation, an awareness that every mind is ultimately isolated within itself. The egg offers a perspective that dissolves both of these fears at once. If every conscious life is simply another expression of the same underlying awareness, then no life is meaningless. Each experience becomes a necessary part of a much larger story. And perhaps more importantly, no one is ever truly alone. In this view, every person you have ever encountered, every friend, every stranger, every enemy, would simply be another chapter of the same consciousness, experiencing life from a different perspective. The boundaries between you and others would no longer be as solid as they appear. The egg offers a comforting picture of reality. It suggests that every experience, every life, and every relationship might ultimately serve the growth of a single consciousness, learning through countless perspectives. But hidden within this idea is an important assumption. It assumes that the universe exists for you, that everything happening across time and space is part of a grand process designed for your development. In other words, it imagines a universe built around a kind of cosmic purpose. But what if that assumption is wrong? What if the universe is not centered on consciousness at all? And what if, instead of nurturing awareness, the universe is actually hiding from it? Which of these thought experiments did you find the most intriguing? Let me know in the comments section below. If you like videos like this, please hit the like button and subscribe, and we will improve at making thought-provoking videos like this in the future. As your body relaxes, let your mind wander to the infinite possibilities this world can offer. After all, the most powerful thought experiment isn't the ones philosophers invented, but the one you're living right now. So maybe the real question isn't which thought experiment was the most fascinating, but what kind of world are you creating